Good afternoon, everyone. Welcome to the second session on AWS Identity. For those of you who just came to this session, this is a second session in the 3-session series on AWS Identity. In the first one, Anders talked about how you can secure access to your AWS environment and what are the top 10 IAM best practices. In this session, I'm going to cover the delegation aspects, and in the next session, Connor, who is another colleague of mine, would go deep into the federation aspects. About me, my name is Shah, and I'm a product manager on the identity and access management team at AWS. I have been with AWS for 2.5 years now, and before this, I was with Microsoft for about 10 years. So let's jump into the agenda. We'll talk about what's delegation in the AWS context. Delegation is a fairly well-known term, but I would like to talk about the AWS context. Then what are the scenarios and what's the technology behind it? We are going to cover 5 scenarios and 3 demos, so I would request you to hold on to your questions till the end. I'm pretty sure we'll have some time. If not, I'm here for all 4 days, and we can always talk. Let's first get some definitions out of the way so that all of us are on the same page. When I say delegation, what I really mean is you want to provide users in other AWS accounts access to the resources in your AWS account. So this is only in the AWS world. Federation, on the other hand, is about providing users in other identity stores access to resources in your AWS account. So the AWS account is still the same, but the users are from other identity stores. These identity stores can be enterprise identity stores like Microsoft's Active Directory, LDAP, or this can be web identity stores like Login with Amazon or Google or Facebook. In this session, as I mentioned, I will go deep on the delegation aspects, and in the next session, Connor will go deep on the federation aspects. Both of us have quite a few demos, so hopefully we'll keep it interesting even when it is that 2 o'clock time and you need 5-hour energy. So here are the 5 scenarios that we'll talk about. The first one is a very basic delegation scenario. It's sort of trivial. You own an AWS account and you want some team member of yours to access resources in your AWS account. You might want to give them lesser privileges than you have, or you might have some group that needs different privileges than another group within your team. The second one is about delegating access to another team, but within your company. For many reasons, we see customers where they own multiple AWS accounts. Sometimes this is because of the mergers and acquisitions. Sometimes because this is the organizational boundaries that are there in the companies. The third one is if you want to provide access to a third party. AWS has a very big partner network. We have more than 7,000 SIs or systems integrators or consulting partners, and 3,000 ISVs or independent software vendors. So if you are using any of their products, and if that product needs access to your AWS resources, what is a secure way to delegate that access? So that would be the third scenario. The fourth one is AWS has 32 services last time I counted in the console. So if you want any of these 32 services to act on your behalf, how you can do that. And finally, we'll talk about how you can delegate access to an EC2 instance. This is the question that came up in the last session, and why it is a magical thing. So stay tuned for that. The first scenario, delegating access to your team member. You have an AWS account, and you can have AWS resources like EC2 instances or DynamoDB table. The way this is accomplished is using IAM users. Anders talked about it. It's a principle in your AWS account. you can grant permissions to that. By default, no user gets any permissions. You have to explicitly grant or deny those. Then you can set credentials. These credentials can be for console access or for API access. And then if this user is going to be a privileged user, we highly recommend you set up an MFA device, or you assign an MFA device to this user. As Anders showed, we support both type of MFAs, a virtual MFA or a hardware MFA. And that's pretty much about it. It's very simple. I'm not going to spend a lot of time on this. This is how the screenshot looks like when you access the console. You can see the access credentials, which are typically used for API authentication. Not that you cannot use that for console access, but typically those are for API access. The sign-in credentials are used only for console access, though. And on the bottom right screen, there is a multi-factor authentication where you can manage the MFA device for the user. Delegating access to another team, but within your AWS account. On the top, there is your own AWS account with your resources. On the bottom, there is another team's AWS account. So the way you accomplish this delegation is using roles. And think of roles as nothing but a bag of actions, bag of AWS actions to be more specific. And then you trust some other entity, you trust some other AWS account to have these permissions. And then the permissions are the ones that you specify on the role itself. So in your account, you create a role and set the permissions. You trust the other account. On the other account side, you ask the administrator of that account to say, now you choose whichever IAM users in your account are allowed to permit this role. So just because you trust another account doesn't mean that anyone in that anyone in that AWS account can start assuming that role and doing stuff in your account. And then, as I said, just with IAM users, even for role assumption, we support MFA. What it means is, even if the IAM user in another account has permissions to assume this role, until he specifies the MFA code, he will not be able to assume the role. And if he cannot assume the role, he won't be able to do stuff in your AWS account. So roles, let me take a little bit of time to talk about roles. There are two policies that we associate with role. The first one is the trust policy. This basically says what is the trusted entity you have. And typically, it is shown using the principal in the JSON policy that you attach to the role. Here you can see that this trust policy says, I'm going to allow account 11111 to assume the role. It's pretty simple, nothing fancy here. The second one is the access policy, and here is where you define all the permissions. And then you can use policy variables that Anders talked about. You can use conditions that Anders talked about. So this is a very simplistic access policy, which says anyone who assumes this role is allowed to list S3 buckets and for all the buckets. So this is sort of list all the buckets in my account, but nothing else. So why use roles? So it is a secure mechanism and controllable mechanism for delegation. Secure because for this cross-account access, all that you hand to the other account is the ARN or Amazon resource name for the role. You never give your AWS access keys. You should never give your AWS access keys because it is as if you are sharing your password with someone else. Moreover, these are what we call as long-term credentials, meaning until you inactivate this access key or until you rotate the access key, those are valid. There is no expiration on them. That's why it becomes sharing secure because of no sharing. The second one is controllable. You can anytime just say, I'm not going to trust that other account. Something bad happened. I'm not going to trust. Or you can say, okay, I will keep trusting, but now you're not going to get the full access that you used to have. So you have a lot of control over the delegation aspects. So let's take a quick look at this demo. In this demo, we'll look at how an IAM user from another account can access AWS resources in your account. So before actually diving into the demo, let's look at the flow because it can be a little bit overwhelming. So this is my AWS account. I have a role called cross-account role that I'm saying I'm going to trust my teams, the product management team's account. And I'm going to grant them only IAM permissions and EC2 permissions, but nothing else. In the PM team's account, I have a user, IAM user called demo, which is allowed to assume this cross-account role. Then I have a Python script, which does following things. And this is where we get into the depth of how roles actually work. The script is going to use the access keys, the long-term access keys of the demo user from the PM team account and access AWS. After that, it's going to assume the role. And assuming the role in my account is going to return it temporary security credentials. And I have a slide on that. I will go into the details. But essentially, you get the access key and secret key that can be used to access resources in my account. And finally, using those temporary credentials, it constructs a IAM sign-in URL, which can be used to access resources in my account. So let's see that in action. We don't have the full screen for some reason. Yeah. Okay. Okay. Thank you. Sorry about that. Hopefully, when we switch over to the PPT, we won't have this problem. So this is my AWS account. You can see all the services. I'm going to go to the IAM console. And here you can see the account number ending with 6238 is my account. In this account, you can just go to the roles, say create role, and we are creating the role for the cross-account access. I will say test, continue, and here are the options. So here I would say role for cross-account access, provide access to the account that I own or within the company. Here you can give the account number for the other account. It's a 12-digit number. I'm just using a fake account number. And here is where you can say whether multi-factor authentication is required for assuming the role or not. Say continue. So you set the trust policy so far. Now you get to set the access policy, where what are the permissions that are allowed for someone who assumes this role. We have around 60 templates here. You can choose any one that you want. There are service-specific template, read-only template, combination of permissions. I'm just going to select read-only, continue, and that's it. This is the setup on my account side. I have already gone through this and used the right account number. So this is the role. And if you look at the trust relationship, you will see that I'm trusting this account, which is our product team's account. And the policy shows the same thing. The principal is that account, and it is allowed to assume the role. On the permission side, I'm saying that it can only do EC2 and IAM actions, but nothing else. Now, you will notice that this has this ARN, or the Amazon resource name that I was talking about. This is the only piece of data that you give it to the other accounts administrator. Let's switch to the other account. I don't have display here, so I'm just going to look there. So this is PM Team's AWS account. I'm going to the IAM console, and here you will see that it uses an alias that Andres was talking about it instead of the account number. And in this account, there is an IAM user, as I was talking about. It's a demo user. And if you look at the permissions, it's using the role R and then assume role permission, nothing else. So we have the setup ready, and now I'm going to start the Python script. So the usage of the script is quite simple. Essentially, it takes the account number in which the role exists and the ARN of the role. And the entire script is available on the blog post, and if you have any questions, we can definitely open up and go into the details. But essentially, it assumes the role, gets the temporary security credentials, and constructs the sign-in URL, and opens up in the browser. So the 6238 is the account that I had, and it opened the role. So if you notice here, now it says this session is the role session, which is the cross-account sign-in role / demo user. And just to prove that this is actually my account, if we go to the IAM console, you can see it is still the account ending with 6238. Remember, the role also allowed only the IAM and EC2 actions. So let's see if we can see the EC2 instances. I go there, I see the running instances, I can look at the running all the instances. If I go to CloudFormation though, I get an error because CloudFormation actions were not granted to this role session. So that's the first demo. And let's get back to the slides. Okay. Now this third scenario is about cross-account access, but when the AWS account is someone else's AWS account. The flow is largely the same. You create a role in your AWS account. You trust the other party. The one thing that changes here is the external ID. And here is the reason. This external ID is a piece of information that only you and this external party knows. The role ARN is not a secret. So, I mean, anyone can know that role ARN. Plus, most of the partner applications that we have, right, are the multi-tenant software as a service applications. So, you want to make sure that that application is allowed to assume the role only if it specifies this external ID, which is particular to each of the customer that the SaaS application has. So it's sort of an extra protection on top of assuming the role. Again, even for this, like if you are providing access to a third party application that is doing some privileged stuff, like I don't know, terminating instances or deleting a table or doing some write actions, right, you can restrict it or protect it using multi-factor authentication. And on the third party account side, right, all that they do is that in their account they have an IAM user for which they say, okay, now I'm granting the permission to assume the role that I have the role on for. So in the wizard that I showed, the second option is for creating a role for third party account access. So let's take a look at this demo also. So this is a demo where one of our partners, Trend Micro, has an application that wants to access my AWS account. So the Trend Micro application is called Deep Security for Web Apps. So it's an application which scans, monitors your web application and make sure that it's secure. So they have two options. You can have your own application running on your on-premises or your data center server, or it can be running on the AWS cloud. So if it is running on the AWS cloud, right, what it does is that it automatically goes and queries your AWS account for all the EC2 instances and finds out all the applications that are there so that it can monitor. But for doing that, right, it needs access to your AWS account. So the flow is almost the same. It uses its own IAM user to authenticate to AWS, and then it assumes the role that you have created in your account and gets the temporary security credentials, and then it can access services like Amazon EC2 or Elastic Load Balancing or Route 53. Let's see this in the action. Okay. Okay, we are back in my account. I go to IAM console. I look at the roles. I have created role for Trend Micro. Here in the trust relationship, you will see another account number. This is the Trend Micro's AWS account number. In their documentation, right, they have steps, and that's where you can find the AWS account number. And for the permissions, these are the read-only permissions on the 3 services that they require. It's good that they do not require write permissions. As Anders was saying, you should always follow the principle of least privileges. Do not provide any other privilege than what is absolutely needed. So the one thing that is different in this role than in the other role is this external ID. And this is what you will see now. So what I'm saying here is that this role can be assumed only if the external ID that is passed is this string called CIS-demo. So let's look at the Trend Micro application. So this is how the UI looks like. I already have one application that is being monitored. So I'm going to go in the administration tab. Looks like it has timed out. Good. Session timeout is a good feature. Okay, we are back again. So they have this web applications tab where you can add web applications. So I'm going to add a new one. And here you see the 2 options that I was talking about, a regular web application which is not hosted on AWS, or web application that is hosted on AWS. So notice that here it is asking only for role ARN and the external ID. not any AWS access keys. So I'm just going to go back to my role, copy the role ARN, paste it here, give the external ID, select a region. In my case, it is US East 1. And now when I click on list web apps, it's going to call the AWS APIs to list resources in my AWS account. One note about external ID, different partners do it different way. There are some partners who generate the external ID every time you add an application or do something, and then you take that and then you configure it in the role. In this case, it's the other way around. Both the ways work fine. So I'm just going to say list web apps, and now it assumed the role, used the temporary credentials from that role, and it has listed all the instances in my account. It has already figured out that this web application is already being monitored, which we saw on the dashboard, and I can go ahead and start monitoring yet another application. So that's the demo for the third-party access, and let's switch back to the slides. Okay, the fourth scenario is delegating access to an AWS service. We have very many services. There are some services who needs to create resources in your AWS account. Just because it is an AWS service doesn't mean that it should have access to your AWS account. So this is a secure mechanism where you are saying a service like OpsWorks or Data Pipeline or Elastic MapReduce can create resources like EC2 instances in my AWS account. Elastic MapReduce is a scenario because it creates like a EMR cluster which can go up to like hundreds, if not thousands of nodes in your AWS accounts. So in that case, again, the flow is pretty much the same. It is based on the roles. You create a role. In this case, you trust an AWS service AWS Services AWS account rather than another team's AWS account. And then you grant the permissions, like again, give only the permissions that are needed. And then what this AWS service does is that it uses the IAM user from its account to do stuff in your account. Now, if you have the CloudTrail logs that Anders talked about, right, you get auditing for that. So you know even if some other AWS service is doing stuff in your AWS account. So on the role creation wizard, the very first option is where you can say services like Cloud HSM or Data Pipeline can do stuff on your behalf. Let's talk about the fifth scenario, and then this is the magical scenario that I was talking about. So you have an AWS account and you have EC2 instances running there. Now, if these EC2 instances want to access AWS service, you need some mechanism to deliver credential to the instance. Mostly what I have seen is that people package the AWS credentials, the long-term AWS credentials, along with the application. It's a very risky thing. There have been some cases where people write this application and it gets exposed or checked into GitHub, and then anyone who has access to GitHub, right, can take this access key and secret access key and do stuff in your AWS account. That's why we say you should never use long-term credentials and embed them in the EC2 instances. Another scenario that I have seen is that customers have EC2 instances with the code along with their long-term credentials. They create an AMI or Amazon machine image from it, and then they start sharing this AMI. So now anyone who has access to this AMI can create an instance, and suddenly they have access to the credentials to access resources in your account. So the way to do this securely is to use roles for EC2. You create a role. In this case, you trust an EC2 services AWS account. And I will show it to you in a demo also. And then you grant permissions. Then you can say, okay, The application that is going to run on my AWS, my EC2 instance just needs S3 and EC2 access, nothing else. So that's okay. You just created the role in your account, but then how are you associating it with the instance? That's where when you launch an instance, you say, I'm going to launch the instance with this particular role. You might have 100 instances, and you might want to use the AWS credentials only from half of them. So this association makes sure that the AWS credentials become available only on those 50 instances. Now, behind the scenes, IAM service and EC2 service works together to deliver these credentials to the instance. You do not have to embed anything. And then the magical part is if you have AWS CLI or AWS SDKs, I think we have SDKs for 6 languages, you don't have to do anything. These automatically pick up the credentials and use those. And again, the way it works is EC2 service has an IAM user which uses to assume the role that you created in your account, and then EC2 and IAM work together to deliver these credentials to the instance. So let's see this in action. In this demo, we'll see EC2 instance which is accessing S3 buckets in your AWS account, but which cannot access DynamoDB tables in your account. Here is how it will look like. I have only one instance I will show, but as Anders was mentioning, if you have multiple instances and if these are part of the auto-scaling group, auto-scaling is a service where you can scale the number of instances horizontally based on factors like the load on the instances. So if you scale out, the new instance will automatically have those credentials. If you scale in, the instance goes away, so no problem. So you create a role associated with one instance or multiple instances. You can associate it with multiple too. And then IAM makes those keys, temporary keys available, and the application on the instance can use it to access S3 or any other AWS service. These are temporary security credentials. They expire after some time. So let's say someone hacks into the instance, right? They will have the access only for limited duration. They won't have this access again. And then these are rotated like multiple times a day. We keep on rotating these. So the key benefit here is that if you have an application that uses AWS SDK, and if you are deploying it on EC2 instances, right, you don't have to do anything. Just run the application, and it will start accessing AWS service. You can modify the permissions on the role, and then you can increase the permissions or decrease the permissions. Let's look at the demo. So I'm going to go back to my account in the IAM console. Let's go to the roles, and here I'm going to show you how to create a role for EC2. Create role, test. Oh, I'm sorry. For some reason, it's not remembering the change. Okay, back again. My account, AWS console, now going into the IAM console. I'll go to roles, create a new role. Let's say test, continue. And here is the option, allow EC2 instances to call AWS services on your behalf. Select. This is the access policy. Here you can say only read only. Continue. That's it. Nothing else. I have already created a role for today's demo. So if you look at this, you will notice in the trust relationship, it says you are trusting the EC2 service. This is the only change. In the cross-account case, you saw the AWS account number either for Trend Micro or another account in your AWS, in your company. Permissions, here we are saying only S3. So, this is fine, but remember I talked about associating it with the EC2 instances. So, let us go to the EC2 instance, EC2 console, launch an instance. In the configuration page, you will see IAM role, and here in the drop down, you will automatically see all the roles where the trust policy says EC2 service is the trusted service. So, the role that we saw is the CIS demo EC2 role. I am not going to create an instance because it takes some time. I do have already created instance, and for the instances that are created with the role, you will see the IAM role field set to the name of the role. That is it. So, now let us look inside the instance. So, this is a Windows Server 2012 R2 instance, the regular one that you create from the AWS console. The only change that I have made is that I went ahead and installed the AWS CLI on this. There is no other change, no credentials, nothing on this one. And now, what I am going to do is going to run this PowerShell script. It is a very simple script. It just runs an S3 command, and then it runs a DynamoDB command, and then it does something else which I will cover quick in a moment. Says list all the S3 buckets. The instance was able to do it. If it was your application using SDK, same thing. It says list tables from the DynamoDB. Oh no, access is denied, which is what we expected. So, how is this magic happening? I mean, there needs to be something using which the AWS services are accessed. So, we have a service called instance metadata service. So, essentially, it is this 169.254, 169.254 URL that is accessible from any EC2 instance. So, it is just a URL. And then if you go to a section of that metadata service, then you can see these credentials, the access key ID, secret access key, and token. I will cover this in little detail, and you can also see that there is an expiration. So, the AWS SDK and CLI automatically look for this location. There is a precedence for looking for the locations. This I believe is the first one, or you can also have an AWS environment variable or the Windows environment variable or a configuration file. This is the most secure mechanism rather than embedding the keys in the configuration file. With that, let us go back to the slides. So, how do these scenarios happen behind the scenes? What is the technology? It is a single service. It is called Security Token Service or STS. All the 5 scenarios that we talked about are enabled by this service. It is a simple service. It has only 6 APIs, and it does one thing really well, and that is it trades the AWS temporary security credentials in exchange for some security token. It can be other AWS credential or security token like SAML assertion or ID token that Connor will cover in the next session. Assume role is the API behind all these delegation scenarios. Basically, when you call that API, it returns a session object, and the session object has the 4 elements. Or the 4 elements. The first one is the access key ID, second one is secret access key. This is the symmetric access key that is used for AWS authentication. The next one is the session token. Now, session token is what, so you use the key to sign the API request, and then session token is what is used by STS to verify that the session is still valid or the session object is still valid. The expiration on this varies from 15 minutes to 36 hours. So remember, this expiration is what makes it a temporary security credential as opposed to the long-term security credential, which doesn't expire at all. And since it can be up to 36 hours for improving your application performance, rather than making the assume role call for every DynamoDB put request or S3 put request, right, we recommend that you cache and reuse. Otherwise, you're just incurring the cost of call on every DynamoDB write. So that's pretty much what I have regarding delegation. To summarize, we covered various delegation scenarios. IAM users enable you to delegate access to someone within your AWS account. Roles are your friends who let you do the cross-account delegation, whether that account is owned by your own company or by a third party. Finally, service roles enable you to delegate access to one of the AWS services so that they can act on your behalf. And this can be service like OpsWorks, Elastic MapReduce, or Data Pipeline, or it can be EC2, where the EC2 instance or applications running inside the EC2 instance can act on your behalf. With that, I believe we have time for questions. Any questions? Yes, sir. Right. So the question is, the session objects or tokens, right? Are these refreshable? And the answer is no. You are right. So once you get this session object, it expires after the expiry. So keep in mind that the assume role call that you make for the delegation scenarios, that itself is an authenticated request. So unless you have some long-term credential, in these scenarios, it is an IAM user from other AWS account that makes a call. So that is the sort of a credential that you have to use to keep on getting the token. But in this token itself, there is nothing that you can use to refresh it.
And in the EC2 example, you had the infrastructure automatically refreshes the token for you periodically every day.
Correct. So for the EC2 case, since we are the IAM service and EC2 service are working in conjunction, right? It uses that IAM user in the EC2 services account to push the credentials. But it's still not a refresh. It's like before expiry of the existing credentials, we push the new credentials. So it's sort of a rotation more than a refresh, if you will. Yes, sir. So let me go back to that slide. So the question was, in case of the third party accessing your AWS account, what's the security policy that you rely on? So again, it is your AWS account and you are in control. So when you create a Trend Micro role in your AWS account, that's where you specify the access policy. Typically what happens is that Trend Micro in their documentation, right, will say, hey, if you want to use deep security for web apps, these are the permissions that we need. So in this case, there were like only read-only permissions. So you just copy that policy, you review it, like if you don't agree, right, then you can just talk to them saying that, okay, why do you need a write access just to scan my web application? But in the end, right, you are in total control of that. Any other question?
I will add to that last answer. It's actually a combination of both third party and you. You set the maximum permissions that the third party has. The third party, when they assume the role and restrict their permissions further, this is where Trend Micro may have two different applications. One application looks at one part of your data, another application looks at a different part. And when they assume the role for the different applications, they could assume a more restricted role for that particular application. So it's a combination of both parties who gives the actual permission.
Right. So Connor has a point. It's a combination. I was speaking more from the account owner's perspective. So if you give permissions, let's say for 10 actions, right, Trend Micro on their end can choose to use only 8 of those 10 for one application and all 10 for other application. But then once the temporary security credentials are gone, right, then that third party has access to all those actions. Okay, thank you so much. I do have the last slide where you can find all the links. We have the AWS Security Blog where you will find a lot of interesting information like the last week launch that Anders was talking about where we have enhanced password policies and then credentials reports also. That was another feature. So all these announcements we make on the AWS Security Blog. We have IAM product details page where you can find information about best practices, delegation, federation. We have 18 partners for SAML. Connor will cover that. So we have links to all those partners' products. We have pretty active IAM forums. So if you have any question, if you just check that out, you will, chances are it's already answered or someone on our team will jump on it right away. And finally, the cross-account access sample code, the Python script, that is also available on the blog post if you want to take a look at it. Okay. Thank you so much for your time and enjoy the rest of the summit.